Okay, so this is going to be a walkthrough of the LANTITE Numeracy sample test from Curtin University. It is available on their website. Now, I'm going to solve the questions and I will explain how I did them. Alright, so let's look at the first question. This is in the calculator available section, so we will also be using a calculator. Now, first question. Alright, we are going to be calculating simple interest using the formula that they have provided. I is the interest, P is the principal amount borrowed, I is the rate, and what we should be doing is we should be paying attention to the fact that they're expressing rate like this. So if the rate is 5% interest, then we are going to put it in the formula as the number 5. Right. T is time period. So in this question, let's have a read. Lisa wants to invest some money for her daughter's future educational expenses. Use this formula to calculate the simple interest Lisa will earn if she invests $5,000 at a 3% interest rate for 5 years. Alright, so we are calculating the simple interest using that formula. So we are looking for I and the information we have right now. She's going to invest $5,000. So this is our principal. We've got a rate of 3 years and we have the time period as 5 years. So in our calculator, what we do is we have 5,000 times by 3 times by 5, and we're going to divide all of that by 100. Okay, so we will just enter that in our calculator. I'll do it as 2 steps. So I'll do 5,000 times 3 times 5 as the first step. That'll give me 75,000, and I'm going to go ahead divide that by 100, and that will give me $750 as my interest. Right, question 2. Group of children are using thermometers to measure and record the temperature in different locations at the school. The thermometer at one of the locations reads the following. And we have been given an image and we should be looking for what the temperature is at the given location. So if we look at this, alright, what the first thing I want to notice is I want to notice that these large increments, we are going up by 20. Now between them, there is a slightly larger line than normal, and it's exactly halfway. So that's going to be 10, okay? Which means for this one, that line is going to be 30. Right, now let's have a look. Between 20 to 30, let's have a look how many little lines I've got. So I've got 1, 2, 3, 4, 5. Okay, so I make 5 jumps to get to 30. So each little one, well, I gotta work out how much there is. So I've got 10 numbers difference between 30 and 20 and 5 little jumps. So each little jump is gonna be 2. So for example, that's 22. Okay. Alright, so from 30 to get to my red line, my temperature finishes here. So I'm going 32, 34 degrees. So the temperature at this location is going to be 34 degrees. Right. Question 3. This time we are given a graph and we're going to need to analyze the graph, okay? So our graph, we've got average household income, expenditure and savings. I can see that I've got amount on this side, so how much, and I've got each color representing something different. So first color represents income, the orange represents expenditure, and the gray represents saving. Alright, I can also see that I've got these as age groups. Alright, now let's have a look at our question. We're answering true or false to the statements. So let's have a look. Household expenditure is less for the 55 to 64 age group than the 35 to 34 age group. Right. Household expenditure means that I'm going to be looking at the orange color for these two groups. Okay, so I'm going to look at the 55 to 64 group. Right, I can see household expenditure, it's over here. It's just under the 100,000 line. Alright, 35 to 44 age group. That's over here. So this one here is lower. So I'm going to say, note this statement is false. So my 55 to 64 actually spend more. Right. The proportion of income as expenditure is greatest for the 15 to 24 age group. That's my next statement. So how I look at this? Well, proportion is like a fraction. So if I need a check, that's what I'm going to do. But first off, I'm going to take an overall look to see which one I think. Okay, that'll help me rule out some answers. So this time we are looking at income. Proportion of income as expenditure. Okay, so we're comparing these two. And this statement says that it's biggest for the 15 to 24 age group. So what I should see is I should see that the orange line is almost as big as the blue line. And just eyeballing it, yep, I can see that these two have the smallest gap, whereas here it's quite a large gap. Here it's a large gap as well, okay? So I'm going to say that, yes, this is a true statement. Alright, C. The age group with the lowest income, expenditure, and savings is the 35 plus age group. So, if this is true, that means that for them, the line should be the smallest, okay? Now, I'm just looking with my eyes, and I can see that overall, this, and this, they all look lower than these ones, okay? If I want to be 100% sure, what I'm going to do is I'm just going to grab a piece of paper, hold it up to my screen just to double check. So I'm going to say this is true. Right. Question number 4. Alright, so we have a table and Sarah wishes to photocopy 10 single-sided black and white pages, 5 single-sided color pages, and laminate 2 A4 pages, and we need to work out the total costs. Alright, so we're going to do this one step at a time, and to get the total cost, we'll just add up everything at the end. So, for 10 single-sided black and white pages, alright, each page is going to be 11 cents. Now, my answer, they've asked for it in dollars, so the first thing I'm going to do is I'm going to change my 11 cents to $0.11. That way I just keep everything in dollars, I don't have to think about it later. I'm going to do the same for the color printing while I'm here, color photocopying. Right, so 30 cents equals to $0.30. Remember, to get from cents to dollars, you need to divide it by 100. So I have 10 single-sided black and white pages, so I'll do 10 times $0.11 for this one. Okay, we'll enter that in our calculator. And that's going to give us $1.10. Alright, we have 5 single-sided color pages, so we'll do 5 times $0.30. And what that gives us is $1.50. And lastly, we're going to laminate 2 A4 pages. Okay, so for this one, there's 2 prices for laminating. And we are going to use this one here because we've got A4 pages. So I've got 2 times $1.20, and that's going to be $2.40. Alright, now I'm going to add this all up. If you want, you can do it in a calculator because this is the calculator section. Alright, total cost for this should be $5. Simple. Alright. Question number 5. Right. So question 5, we have a map of Curtin Bentley campus and we're answering true or false to the following questions. So I've been told building 204 is to the north of building 202, and I need to say, is that true or false? So first off, let's look for the buildings. Right. I can see building 202 is here. and I can see building 204 is here. Now on my map, it also tells me which direction is north. So if I go straight up like that, that's north. I'm going up, so yes, I would say this is true. 204 is north of 202. B. When walking from building 211 to building 309, following the Rob Riley walk and going past building 204, creative quarter is on the left. Alright, so let's have a look where these buildings are. Building 211. Now, where is that? That is here. To building 309. That's over here. If we follow the Rob Riley walk and go past building 204, I marked 204 in a different colour for us. So we're going to go and walk this route, okay? I'm going from here and I'm going past building 204, okay? Is creative quarter on the left. Alright, let's have a look. Might need to zoom in, Chad. Where's creative quarter? Found it. Okay, so creative quarter is this one over here. So let me color it. This is creative quarter. Alright, so if we're walking this way, so imagine you're standing on the walk. This side is your left, this side is your right if you're walking in that direction, right? So creative quarter is on our right. That means that this statement is going to be false. Alright, now next one. We have a question that says building 215 is approximately 100 meters long. Okay, now in this map, what it says is that the grid square is 75 by 75 meters. So that means each square is going to be 75 meters. So building 215, if it's approximately 100 meters long, should be 1 and a bit boxes. So let's look for building 215. Alright. Now building 215, this is it. Okay. That's how long it is. Oops, sorry. Let me do that one more time. Alright. This is how long building 215 is. And this is how long a grid square is. So we can see it's definitely not bigger than the square. So that means this is going to be a false statement. Right. Question number 6. A large garden bed with a perimeter of 50 meters has a section removed as shown above. What is the perimeter of the new garden bed? Okay, so how we do this, what we notice is that I had a rectangle originally, and then now I've got a rectangle and I've cut out a bit. But a lot of people, they would think that this means that the perimeter decreases. It actually hasn't, because I will show you guys the old perimeter and then we'll map it out on the new garden bed, okay? So the old perimeter, let's follow it in green. So that's that line here. Okay, all right. This bit's here. I can see that here as well. This bit's here. Yep, that's all there. All right, now this bit, okay? It's like that. So on the new garden bed, what that looks like is here, here to get the middle bit, and then here. So that's all of the old garden bed. Now remember that the old garden bed was 50 meters, okay? So the green lines that I've drawn here, that equals to 50 meters. I've got 2 new sections, okay? 2 new bits added to the perimeter. That's this bit and this bit, okay? So I'm going to have my old perimeter, my 50 meters, and I'm going to add 2 meters and a second 2 meters, okay? And in total, that is going to be 54, okay? So the new perimeter is going to be 54 meters. All right. Alright, continuing on with question 7 in the calculator section of the Curtin University paper. Alright, so question 7. A school excursion is scheduled for Thursday, but will be cancelled if it is raining. The Bureau of Meteorology predicts a 40% chance of rain. What is the probability that the excursion will not be cancelled? Okay, so in this question, if it rains, it's cancelled, okay? And you have 40% chance of rain. What's the probability that it will not be cancelled? So in this question, what I'm looking for is, I'm looking for the probability of not raining, okay? And I've got 40% chance of rain. Now I can see my answers are expressed as fractions. Now, in probability, you have 100% chance of something happening, okay? So I've got 100% chance of something happening, and my options are either rain or not rain, okay? So if I do 100% minus the chance of rain, so minus 40%, then what's left over is the percentage probability that it will not be raining. So in this case, I've got a 60% chance of not raining, okay? So this 60%, that is related to this thing here, okay? So 60% chance of not raining. Now, my answers are in fractions. So what I need to do is I need to convert this 60% to a fraction, okay? Now 60%, any percentage is the same as saying that number. So 60 over 100. Now we are going to simplify that. So easiest way to simplify things, if you've got multiples of 10, aka you got zeros at the back. Right, let's chop off both these zeros. Right, 6 over 10. Fractions, you always need to simplify it as much as possible. Now I can divide both of these by 2 to simplify it, okay? So 6 divided by 2 is 3, and 10 divided by 2 is 5. So 3 over 5 is going to be my answer, okay? So I've got a 3 over 5 probability that the excursion will not be cancelled. Right. Question 8. The diagram above shows an A0 sheet of paper, and it's got some measurements, and it's almost exactly 1 square meter in area. Right. And then it's talking about the other sheets of paper. And what's my question asking? Alright, what is the area in square centimeters of an A3 sheet of paper? Alright, so let's have a think. I've got my A0, that's my original piece of paper, so this whole entire thing here, that's going to be approximately 1 square meter in area. Alright, now the A1 sheet is half the area of the A0 sheet, okay? So this one's the A0. A1 is half the area. So that means that A1 is going to be 0.5 meters squared. Okay? Half a meter squared. Alright, A2 is half, and so on and so on, okay? So if A2 is half, alright, half of this, 0.25, okay? So to find half, remember you divide by 2. Alright, what is the area in square centimeters of A3? Alright, A3 is 0.125 meters squared. Right now, this is in meters squared, and your question is asking for square centimeters, okay? So we need to change meter squared to centimeter squared. Now, what you need to be careful of is that 1 meter squared, okay? Some people might think it's the same as 100 centimeters squared. That is not true, okay? So if you think about it, 1 meter squared, that's equal to 1 meter times 1 meter, which is the same as saying 100 centimeters times 100 centimeters. Okay, so 1 meter squared is actually going to be like this. Okay, so 1 meter squared is equal to 10,000 centimeters squared. Okay, so if my A3 sheet of paper is 0.125 meters squared, then my A3 sheet of paper, if I'm working out the area as centimeters squared, what I'm going to do is I'm going to take this number, 0.125, and I'm going to times it by 10,000, and that will give me my answer. You can enter this bit in your calculator. 1,250 centimeters squared. So this one here is our answer. Right, moving on. Question 9. A school disco is being held for 90 students with catering provided. At a previous disco for 56 students, the catering included 224 pieces of sushi. How many pieces of sushi should be ordered for the upcoming disco to ensure the same allocation of pieces per student? Alright, so this is a question that we can work out as ratios, okay? So for the previous disco, you had 56 students and there were 224 pieces of sushi. So what we want to know is how many pieces of sushi did each student get, okay? So that means I'm trying to work out one student, how many pieces of sushi. Alright, it's a ratio. So whatever you do to one side, you do to the other, okay? So to get from 56 to 1, what I'm going to do is I'm going to divide by 56. If I divide this side by 56, same thing's going to happen to the other. Alright, so let's do 224 divided by 56, and that means that each student, they're going to get 4 pieces of sushi. Alright, so I know how many pieces of sushi each student gets now. Now we need to work out how many pieces of sushi are we going to order, okay? So that's what the question is asking. Alright, well, I've got 90 students, and I need to work out how many pieces of sushi to order. To get from 1 to 90, I times by 90. So, to figure out how many pieces of sushi, I'm going to times 4 by 90. Okay? So, 4 times 90 will give you your answer. You can do that bit in a calculator if you want. And that's going to be 360, okay? So, we are going to order 360 pieces of sushi. Right, question 10. Lucy and John are playing a game with 2 dice, and Lucy needs to roll an 11 to win. What is the probability that the top numbers on the 2 dice sum to 11 on her next turn? Alright, so we've got 2 dice, okay? So let's say this is dice number A, dice A, dice B, okay? She needs to roll an 11. So let's think about, on a dice, what numbers we can have that add up to 11, okay? So realistically, your dice, it's 6-sided, so you've got numbers 1, 2, 3, 4, 5, 6. Now, if they add up to equal 11, then what you are looking for is one of the dice to have a 5. So I can have dice A roll a 5 and dice B roll a 6, or I could have it the other way around, really. Alright, question 10 of the Curtin University Numeracy paper for LANTITE. Lucy and John are playing a game with 2 dice, and Lucy needs to roll an 11 to win. What is the probability that the top numbers on the 2 dice sum to 11 on her next turn as a fraction in the simplest forms? Okay, so we've got 2 dice, okay? So let's say I've got dice A and I've got dice B. And we need them to roll numbers that add up to 11. Now my dice, well, a dice you always have numbers 1 to 6, okay? So 1, 2, 3, 4, 5, 6 for one dice, and same on the other dice. Alright, now the only way that you can get an 11 as your sum is if on one dice, so say dice A rolls a 5, then dice B, we need it to roll a 6. Or what we can have is dice A rolls a 6 and dice B rolls a 5, okay? So if we have that, then we will have 11 as our sum, which is exactly what we want, okay? So there's two options where we can roll 11, okay? Now let's think about how many different options we have in total, okay? So dice A can roll 6 different numbers, okay? So dice A can roll 6 options. Now dice B can also roll 6 different numbers, right? So I've got, let's say dice A rolls a 6, okay? So let me just show you guys what that looks like. So let's say that I roll a 6 with dice A. Now for B, dice B, I could roll a 1, a 2, a 3, a 4, a 5, or 6, okay? So for every number of A, we could have 6 different options, 6 combinations that we roll for dice B, okay? So that's why we're going to say dice A, we can roll 6 different numbers. Dice B also gives us another 6 combinations. And we are going to multiply them together, because for every single number that we roll for dice A, we've got 6 different possibilities in dice B. So 6 times 6 is going to be 36, okay? Now, we are going to say, we had 2 options where we roll an 11. So there's 2 viable options. I'm going to write it over here, okay? I've got 2 viable options out of 36. Let's simplify this. Well, I can divide both of these by 2, so 1 divided by 2 is 1. 36 divided by 2, 18. Alright, so the probability that we can get 2 numbers to sum up to 11 is going to be 1 out of 18. So that's my answer. Alright, moving on. Question 11. A machine in a supermarket is set to cut slices 2.6 millimeters thick from a piece of salami that is 33.8 centimeters long. How many slices can be cut? Alright, so basically I'm trying to figure out how many slices fit into this piece of salami. One of the things that you should notice straight away is that I've got different units. So here I'm in millimeters, here I'm in centimeters, okay? It doesn't matter what unit you use, but you need to have the same units. So for this scenario, I'm just going to say I'm going to change the piece of salami and I'm going to turn that into millimeters, okay? So to turn centimeters to millimeters, we times by 10. So I'm going to have 338 millimeters, okay? Now I want to know how many slices fit into this piece of salami. So I'm going to say, well, 338 divided by 2.6, okay? So calculator section, use your calculator, work that out, and let's see what that gives us. So if you put that in a calculator, what you're going to get is 130. So you can get 130 slices out of this piece of salami. Not bad. Alright. Question 12. Chris is considering buying a large custom-made fish tank with the following dimensions. And we've got a drawing of that fish tank. Alright. What is the volume of the fish tank in cubic meters to 2 decimal places? Alright, so one of the things I notice is that my fish tank is an L shape. Okay, well, let's see how I will do this. So, best way to do this is you're going to divide up this shape into 2 rectangles, okay? I'm going to, let's have a think. let me divide this rectangle up like this, okay? So I've got a rectangle at the top, okay? It's like that. And I've got a rectangle at the bottom. Alright, so let's see what I know now, okay? So the rectangle at the bottom, I'll do this in green. I know that this side is going to be 1 meter. I know that this side is 0.5 meters. Now I'm working out volume, so I need length times depth times height, for example, okay? So I need to figure out what this number is. Alright, now if I have a look, this top side, okay, that's the same length as this number here plus this number that I'm missing. So to work out that missing number, I'm going to say this bit is equal to 2.2 minus 1.4. Okay, so 2.2 minus 1.4, that equals to 0.8 meters. Alright, do I need any other information? Yes, I do. For the top rectangle, to work out the volume, what do I need? Okay, I've got that side in red already. Oops, side in red I said. Alright, now do I have this side? Yes, I do, because it's the same as this one. So this is also 0.5. Alright, all I need now is how much this bit is. So to do that, I know that my entire length for that section, so this bit, that's 1.5 meters. And I know that this bit here, that was 1 meter. So that means that the bit I'm looking for, this section here, well, that's got to be 1.5 minus 1 meter, which also equals to 0.5 meters. Alright, so let's work out the volume of the top rectangle now, okay? So the top rectangle, to work it out, we're going to do 2.2 times 0.5 times 0.5. And if you enter that into your calculator, what you should get is 0.55 meters cubed for that section. Now the bottom section, let's see what that's going to be. So for the bottom section, we had this side here, so 1 times this one here, which we worked out as 0.8, times this section here, so 0.5. So that bottom section, let's put that in the calculator. Alright, that's going to be 0.4 meters cubed. So in total, it's going to be the two rectangles added up. So let's add that. Okay, so we've got 0.55 meters cubed plus 0.4 meters cubed. Okay, and my answer is going to be 0.95 meters cubed. Now this, let's check. We want 2 decimal places in our answers. We have 2 decimal places. All good to go. Alright, 0.95. Alright, question 13. A school purchased 30 large bottles of paint online and pays $12 for delivery. If the total cost of the order is $522, what was the price per bottle of paint? Okay, so we have this as the total, okay? So the total price is equal to delivery plus cost of paint. Okay. That means that the cost of paint is going to be equal to 522 minus $12. Okay, so what that is going to give you is $510. Okay, so that's the cost of all the paint, and it's 30 bottles. Okay. Alright, I want to work out how much one bottle costs. So what I'm going to do is I'm going to split that 510 by 30, okay? So 510 split up by 30, so I divide it, and we'll just enter that in our calculator, 17. So each bottle of paint is equal to $17. Right. Question 14. Mike's resting heart rate is 70 BPM, beats per minute, but during exercise it increases by 30%. What is Mike's heart rate during exercise? Okay, so his heart rate is going to increase by 30%. Okay, now to do this question, it's very good if you know how to convert 30% into decimals. Now to convert a percentage into decimal, what you do is you take your number, so you take 30 and you divide it by 100, I'll give you 0.3, okay? So 30% as a decimal is 0.3. Now, his heart rate is going to increase. So what we do is we have the original heart rate and we're going to add 0.3%. 0.3, okay? Oh, we're going to add 30%. So we're going to say that his original heart rate, 70 beats per minute, that's 100%, okay? Which as a decimal is 1. So shortcut way to do this is we have 70 beats per minute times by 1.3, okay? So you have 100% as the 1 plus your 0.3, okay? All right, so put that in a calculator. Is 91, okay? So his heart rate during exercise is going to be 91 beats per minute. Alright, question 15. Okay, a raffle contains tickets numbered from 1 to 30, of which 1 is drawn at random. What is the probability that the number of the ticket drawn is not a multiple of 4 or 5 as a fraction in the simplest form? Okay. So we're looking for the number of tickets that are not multiples of 4 and 5. And it's between the numbers of 1 to 30. So first thing I'm going to do is I'm going to figure out how many numbers are actually multiples of 4 and 5. So let's make a list. Multiples of 4 between 1 to 30. Alright, I've got 4, 8, 12, 16, 20, 24, and 28. And next one will be 32, which is over, so I can ignore that. Alright, multiples of 5. So I've got 5, 10, 15, 20, which I've already written, so I don't need to write that again, 25, and 30. Okay, so let's see how many numbers are a multiple of 4 and 5 here. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 numbers that are multiples of 4 and 5. So how many numbers do I have that are not a multiple of 4 and 5? Okay, so that's 30 minus 12. That would give me 18, okay? So I've got 18 numbers that are not a multiple of 4 and 5, okay? So what's the probability that I'm going to draw these 18 numbers? Well, it's going to be 18 out of 30. Now, I can simplify that a bit. They're both even numbers, so I'm going to simplify it by dividing both of these by 2. So 18 divided by 2 is 9. 30 divided by 2 is 15. Ooh, I think I can simplify that even more because I can divide both of these by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. Do they have any more numbers they can both be divided by? Nope, that's it, okay? So my answer is going to be 3 out of 5. There we go. Alright, moving on. Question 16. Alright, so I've got a graph, and this graph is about the employment rate of 25 to 64-year-olds with tertiary education, and it's by gender. Alright, so I've got different countries I can see, and percentages at the bottom, men, women. Alright, let's read what I need to answer. The graph above is adapted from the report in 2012. True or false? Chile has a lower rate of employment than Italy for both men and women with tertiary education. Alright, so let's figure out where Chile is. Alright, Chile, that's this one. Oops, that highlight's a bit big. Alright, and the other one I'm looking at is Italy. So let's do Italy as well. Alright. So, true or false, Chile has lower rate of employment for both men and women. Alright. So Chile, for women, their rate of unemployment is a bit above 70 for women, while Italy's is a bit further above. Okay, so for women, it's true. Okay, but we're saying both, so let's have a look at for the men. Alright, for the men, Chile's rate of unemployment, that's here. Okay, so that's roughly what, I don't know, 88%. Whereas Italy, for the men, it's, I'd say that's closer to 85. So for Italy, for that one, Italy has a lower rate of unemployment. So I would say lower rate of employment. Yes, that's correct. So that means for this one, it's false. So I'm going to answer false here. Alright, question 17. Oh, that's all for the graph. Okay. Alright, question 17. The highest mark in a class for a test was 57 out of 60 and the lowest mark was 24 out of 60. What is the difference between the highest and lowest mark as a percentage of the total available marks? Okay, so first off, let's work out what the difference between the highest and lowest mark is, okay? So that's going to be 57 minus 24. And we'll put that in our calculator, or you're going to do it by hand, completely up to you. This is the calculator section though, so it doesn't hurt to use it. So 57 minus 24, that's going to be 33. Alright, now the next bit, you probably want your calculator, because we need to work this difference out as a percentage of the total available marks, okay? So because it's of the total marks, that means we have to do it as 33 over the total marks, which is 60. And if you put in your calculator, okay, 33 divided by 60, that would give you a percentage as a decimal. So let's go ahead and do that. That's 0.55. Now to get it as a percentage, we're going to times this number by 100. That'll give us 55%. So the difference here is 55%. Alright, question 18. A student advisor is creating a timetable for consulting with students. She plans to see each student for 20 minutes and to see students in 2-hour blocks of consecutive consultations. If the advisor needs to see 45 students, what is the minimum number of 2-hour sessions she will need to schedule? Alright, so we're working with 2-hour blocks and each student is 20 minutes, okay? So basically in each block, okay, so in a block, got 2 hours, which is 120 minutes. And if we're seeing each student for 20 minutes, well, to figure out how many students we can see, we're going to divide by 20. Alright, so each block, she can see 6 students. She has 45 students she needs to see. So, well, let's divide 45 by 6 to see how many blocks we need. Okay, so we need 7.5 blocks, okay? And, well, we can't really do a half block. So that means that we are going to round up and we are going to need 8 sessions, okay? So she needs to have at least 8 2-hour sessions to see all of these students. Right. Question 19. Right, so we've got a table and it's talking about modes of transport to work. All right. The survey was administered to 200 people, and we've got true or false. So true or false, 6.25% of people who ride their bike to work are female. All right. Ooh, this is kind of weirdly worded. All right, 6.25% of people who ride their bike to work are female. Okay, so how many people do I have riding their bike to work? I have 17, and 5 of them are female. So we're doing 5 over 17. Right, 5 over 17. And as a percentage, that would be 29%. So I'm going to say that is going to be false. Right. True or false, the percentage of males who take public transport to work is less than the percentage of females who take their car to work. Alright, so let's have a look what percentage of males take public transport to work. And I'm assuming this is now asking me as a total. So males, public transport to work. Alright, that's here. Okay, so I have 61 males that take public transport to work, and as a percentage, we have 200 people in total, so as a percentage, this is going to be 15.5%. Alright, what about females who take their car to work? Alright, so I have 43 females. So, same thing. Throw that in a calculator. That's 21.5%. Okay, so I have more females taking their car to work, so this is going to be a true statement. Right, question 20. Jenny is redecorating her bedroom and wants to cover one of the walls with wallpaper. She measures the wall and finds that it's 3 meters wide and 2.8 meters high. If the wallpaper she liked costs $25 per square meter, how much will the wallpaper cost in total? Okay, so she wants to cover one wall, and the wall is 3 meters wide and 2.8 meters high. Right, now to find the area of this wall, we're going to do 3 times 2.8. Okay, so 3 meters times 2.8 meters. Enter that in a calculator. You should get 8.4 meters squared. Okay, now it's going to cost her $25 per square meter, so we're going to work out the total cost by doing 25 times 8.4, and we get 210. So she needs to spend $210 on this wallpaper. Alright, question 21. The Roman Empire period of ancient Rome lasted from 27 BC to 476 AD, inclusive of both years. Given that the year 1 AD follows the year 1 BC, how many years did the Roman Empire last? Alright, so basically what this looks like is 27 BC, okay, and we're going all the way backwards to 1 BC. So here, that's 27 years here. And then after 1 BC, we have 180. Okay, so that's another year. And then we're going all the way up until we reach 476 AD. So there's 476 years here, okay? So to figure out how many years the Roman Empire lasted, let's add up all of those years. So we're going to do 27 plus the 1 plus 476, and that should give us 504 years. It's a long time. Alright, 22. At Mary and Robert's wedding, 42 of the guests were Mary's family. If this accounted for 30% of the total guests, how many guests were there in altogether? Alright, so 30% of the guests are Mary's family. So 42 30% equals to 42 people. Alright, how many guests were there altogether? Alright, well, that means I need to work out how many people 100% is, okay? So to do this, I'm going to figure out how many people does 1% represent. And how I do that is, well, 30% is 42. So to get to 1%, I'm going to divide it by 30, okay? So I'm going to put 42 divided by 30, and 1% is 1.4 people. Alright, so 100% is going to be 140 people at this wedding. So there we go. Question 23. Amount of calcium needed each day, and we've got age in years on the side. So the graph shows how much calcium children need each day. If Hannah is 3 years old and Luke is 10 months old, how much less calcium does Luke need each day compared to Hannah? Okay, so first thing to do is we'll work out how much calcium Hannah needs and how much calcium Luke needs, and then afterwards we can do the difference. So Hannah is 3 years old, that's here, okay? So how much calcium is she going to need? That's here, okay? So Hannah is going to need 750 milligrams. All right, what about Luke? Luke's 10 months old, so that's this one here, okay? All right, so that means Luke needs 550 milligrams per day. Let's work out the difference. That's going to be 750 minus 550, which is going to be 200 milligrams. So Luke needs 200 milligrams less. Right, 24. The Venn diagram above shows the results of a survey completed by 330 people in regards to the reality TV shows they watched. Given that 160 participants stated that they watch The Block, what are the number of participants who watch MasterChef and Survivor, but not The Block? Alright, so they're watching MasterChef and Survivor, but not The Block, okay? So basically, let's figure out what area we're looking at. So MasterChef and Survivor, that's this region here, okay? And we want people that watched both of them. So really, we're actually looking in this region, okay? I'm not going to include that 10 because if I included the 10, that means they also watched The Block. Alright, so let's have a look. 160 people stated that they watched The Block, okay? So The Block has 160 people that watch it. There's 75 people that watch just The Block. So 75 people from there. I'm just going to write TB for The Block. Okay, so 75 that watch The Block only. I have 42 that watch The Block and MasterChef, and I have 10 people that watch The Block, MasterChef, and Survivor. Now the only number I don't know is how many people are here, okay? So how many people watch just The Block and Survivor? And the reason I want to know that is because I know that 330 people watched TV shows and they were surveyed, and I know 160 of these people watched The Block. So I need to find this number here, and then afterwards I have every number in this Venn diagram except for this one, which is the one I need to find out. So let's find out how many people watch The Block and Survivor, okay? So The Block, 160 people watched it. That means that 160 comes from the 75 plus 42 plus 10 plus this mystery number, okay? So we're working out what the mystery number is. So to do that, we're going to do all of these numbers added together, and we'll do 160 minus that. So 160 minus 75 minus 42 minus 10, that's going to be 33. So this missing number is 33 people. Okay. Alright, so I know I've got 33 here. Alright, now in total in this Venn diagram, I know that I have 330 people. So I'm going to add up all the numbers that I have right now, and that will tell me how many people are left here, because everything added up should equal 330. So let's go ahead, we'll add up 75. So 75 plus 42 plus 58 plus 10 plus 33 plus 12 plus 32. So there's still the calculator section, so we'll add that up in a calculator. That's 262 people. And I know that this survey was completed by 330. So my leftover, the people that I missed, they must be in this yellow bit here, okay? So I'll do 330 minus 262, and that'll tell me how many people I missed. That's 68 people. So that means 68 goes here. So 68 people watch MasterChef and Survivor, but not the block. There we go. Alright. Question 25. Jessica has a large number of assignments to mark. The plan is to mark a portion each day. On Tuesday, she awards the following marks. What is the average mark for these assignments? Okay, so to find an average, what we do is we add up all the numbers together and then we divide by how many numbers we did. So let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so we'll do the sum of everything over 8 to get our average. Okay, so we'll do 48 plus 33 plus 45 plus 36 plus 29 plus 44 plus 38 plus 31 in your calculator. So we have 304 over 8. So in our calculator now we'll put 304 divided by 8, and that will give us 38. So the average mark for these assignments is going to be 38. Alright, last question of the calculator section. Luke has a container with the dimensions shown above. Given that a cube with dimensions 10 centimeters by 10 centimeters by 10 centimeters holds 1 liter of liquid, how much liquid would Luke's container hold? Okay, so one way we can do this is we can figure out how many blocks of 10 by 10 by 10 go in here. Or another way is we figure out how many centimeters cubed Luke's container is and how many centimeters cubed holds 1 liter, okay? So I'll start with that. So I'm going to work out 1 liter. How many centimeters cubed does it equal to, okay? So 1 liter is equal to 10 centimeters times 10 centimeters times 10 centimeters. So I'll do 10 times 10 times 10. That'll give me 1,000 centimeters cubed, okay? So I know 1,000 centimeters cubed is equal to 1 liter now. Alright, now let's work out the volume of Luke's container, okay? So Luke's container is going to be, for volume, it's going to be 35 centimeters times 15 centimeters times 20 centimeters. So I'll do all of that in a calculator. 35 times 15 times 20, that's 10,500 centimeters cubed. Okay, so I've got 10,500 centimeters cubed. How many liters is that? Well, let's get from here to here. So I'm going to divide by 1,000 and that'll tell me how much fit in. So 10,500 divided by 1,000 is equal to 10.5. So this container is going to hold 10.5 litres of liquid. Alright, that's the end of the calculator section. So we'll put calculators away. We'll do the rest of this by hand. Alright, non-calculator section, question 27. 54,000 people attended a football match. Of these, only 25% were supporters of the visiting team. How many people were supporters of the visiting team? Alright, so we need to work out 25% of 54,000. Alright, now for me, one way I like to do this is I know that 25% is the same as a quarter. So it's the same as 1 divided over 4. So I'm just going to find a quarter of 54,000. So I'll do that by dividing 54,000 by 4. So do some long division. Alright, how many 4s go into 5? 1 goes in. Got 1 remainder. How many 4s go into 14? 3 go in, because 12, and that gives me 2 remainder. How many 4s go into 20? 5 of them do, with no remainders, and I've got 2 zeros remaining. So put the zeros back. That means 13,500 people were supporters of the visiting team. Right. 28. So I've got 2,500,000 Western Australians surveyed in the 2016 census. Approximately 8% indicated that the country of birth was England. How many Western Australians were born in England? Right, this time, just because it's easier to do it this way, I'm going to do the percentage as a percentage, okay? Or as a fraction. So 8% is the same as 8 over 100. So I'm going to figure out 8 over 100 of my Western Australians. Okay, so you times by the number on top and divide by the number at the bottom. I'm going to do the division bit because it's 100. So if I knock these 2 zeros off, I can knock these 2 zeros off. The rest is 8 times 25,000. Okay, so how I do this is I do 25 times 8. I'm going to ignore the zeros. I'll just put them back at the end. So 8 times 5 is 0. It's 40 actually, but the 4 is up top. Right, 8 times 2 is 16. And we got to add on the 4. So 16 added on 4 is 20. And then I had 3 zeros behind that I ignored earlier. So let's put them back now. Okay, so I'll just drop them down. 1, 2, 3. That is 200,000 people. Right. 29. The table below above shows the results of the men's 100-meter final at the Olympics. True or false, the runner who finished 4th was in lane 9. Okay, so that means I need to figure out the order that these runners finished. So let's figure out who ran the fastest. I'm looking for the smallest number. Alright, so lane 4. This person came first. I might just write a 1 above them. Okay. Second smallest number. Oh, sorry, I missed someone. No. Lane 4 didn't come first. Lane 6 came first. Right, so this runner came first because 9.81 is the smallest number. Second smallest was lane 4, so they came second. Right, third smallest number here. That's 9.91, so this person's come third. Right, what's smaller next? Lane 9 is the next smallest. So this person came 4th. So true or false, the runner who finished 4th was in lane 9, Blake. Yeah, that's true. Tick. Right, question 30. Lisa is buying cereal for a fundraiser breakfast. If each box of cereal contains 720 grams and Lisa buys a carton containing 10 boxes, how much cereal will she have in kilograms? Alright, so first off, let's work out how many grams are in these 10 boxes, okay? So we've got 700 20 grams, and we've got 10 of them. So we'll times that by 10. So I've got 7,200 grams now. Now to get from grams to kilogram, what we do is we divide by 1,000. So let's divide this number by 1,000. So how I divide by 1,000 is, I think, where's the decimal? Here's the decimal right now, okay? To divide by 1,000, 1,000 has 3 zeros, so I need to move the decimal 3 times, and I'm making the number smaller. So I go 1, 2, 3, okay? So that means that I've now got 7.2 kilograms. So 7.2, done. Question 31. A deli purchases salad in 3.6 kilogram bags, which they repackage and sell in 450 gram tubs. Whew. How many tubs can they fill from each bag of salad? Alright, so we need to figure out how many tubs fit into this how many tubs can we fill up with 3.6 kilograms, okay? So 450 grams. Let's see. So I've got my first tub, 450. Alright, my second tub is 450. Now 2 tubs make up 900 grams, okay? Which is going to be an easier number for me to work with, because 900 grams, well, 9 times 4 is 36, and this is 3.6 kilograms. 3.6 kilograms is the same as 3,600 grams, okay? And I know that 4 times 900 gives me 3,600. So I know that I have 4 of these 900s that go in. If I've got 4 of these, that means, so if I have 4 900s, that means I have 8 450s. So I can fill up 8 tubs. Okay, question 32, last question. Alright, a country has a population of 8,300,000, of which 2,500,000 live in rural areas. What is the closest approximation, okay, so we're just approximating, to the percentage of the population who don't live in rural areas, okay? First thing I'm going to do is I'm going to figure out how many people don't live in rural areas, okay? So what I notice about these numbers, I've got 8,300,000 and 2,500,000. One way to do this is I like to do a little trick where I see that we've got the same number of zeros in both of these. So I'm just going to actually ignore the zeros, and I'm going to treat it as 83 and 25. So let's do this subtraction, okay? 3 is smaller than 5, so I'll borrow a 1 from here. 13 minus 5 is 8. And then I've got 7 minus 2, that's 5. Alright, so my fraction is going to be 58 over 83. Alright, now I need to figure out what percentage of this. Okay, now, well, I'm going to look at these numbers. They're not very nice numbers. So the way I'm going to do this is looking at these possible answers. I can see that they're all multiples of 10. So something I might consider doing is thinking, what is 10% of 83? 10% of 83 is going to be 8.3, okay? So how many, 8.3, that's pretty close to 8. So let's say how many 8s fit into 58, okay? So how many 8s fit into 58? And that's going to be 7 with a bit remaining, okay? So I think that the closest thing is going to be, I've got 7 10%, okay? So that would be roughly 70%. So that's going to be my answer here, 70%.